Hello everyone, this is Dr. Jones and we are now into Chapter 18 titled Recursion, and this lecture will only focus on the first part of Chapter 18, specifically just part, 18.1 to 18.3. So for this lecture we're going to talk about the basics of recursion, the components that are involved with recursion, so the structure that is required to do recursion. I'm going to provide an example, a common example that's provided in the book on how to use recursion, and I'm also going to compare it with iteration. And then we're going to actually look at recursion versus iteration and talk about the similarities as well as the differences, and coming at least understanding some of the strategies when determining which method to employ. So let's begin with a quick rundown of the basics for recursion. Recursion pretty much just means a method that invokes itself. So I've created a method, and inside that method I am going to call that same method. That's what recursion is. Recursion is an alternative to iterative loops. We discussed these iterative loops back, I think it was chapter 5 from 2301. So these are your while and for loops. Now, recursion, or a recursive method, provides an elegant solution to problems that are difficult to program using a while or a for loop. I think to date we probably haven't encountered any complex problems where that would make sense. The book will show you a few, and we'll talk about some of those problems in this lecture as well as the next lecture as well. But hopefully you'll see how when we use recursion, it leads to a very straightforward and simplistic solution. And if we try to do that with a loop structure, it would be a little more cumbersome. Now let's look at a simple while loop. And again, we've been using while loops since, I think it's chapter 5, maybe chapter 4. I can't remember which chapter it was, but since the early days of 2301. We just have a simple while loop here, and I'm using comments to show you what's going on. We start with a variable, and we have to initialize that to a start value. Then inside our while, we will examine if that variable has reached a terminal value. If it hasn't, then we go inside our while block. We'll do something, whatever we do. This doing something is the iteration that helps us get to our solution. Once we've done something, we want to make sure we increment our variable so that it gets closer to the terminal value. If we don't do that, then we have an infinite loop, and we stay in this until that variable gets to the terminal value. So every iteration we're going to do something. Every iteration we're doing something, and we increment. Once we've finished with that while loop, then we typically would do something else that has to do with what we were doing inside the while loop. Usually it's going to be a printout, or we're going to use what was computed in another computation. It really depends on the problem. This is a very generic layout of a simple while loop. But again, let's just be clear what some of the components we need. We need to have a variable that starts at a start value. Inside our while, we're going to check to see if that variable has reached a terminal value. Then we're going to do something in that while loop. If we don't do something in the while loop, then it kind of defeats the purpose of having a loop. And then we're going to increment our variable to the terminal. And then outside the while block, we will then do something with whatever was associated with what we were doing inside the while loop. So let's look at recursion. And I'm using comments, and I'm pointing you back to the line of code that ties back to how it would be represented inside of a while loop. So you guys feel free to go back and forth to mix and match and see how things line up. But here we go. So our first step is to, well, I don't want to say first step, but one of our early steps is to invoke the method. We're going to first invoke the method. We're going to pass in a value. we can set that value first and then pass it in. More likely that's what we would do. We would have a variable, have that variable set to a value, and then we're going to pass in the value. I'm sorry, passing the variable. But in this case, I'm just passing in a value. So inside our method, well, let me go down one more line. So once this method is done, it's going to produce a val, and then we're going to do something with that value. So in this case, we may do a system out.println of what val is. Now let's go inside our method. So this method is getting invoked at step A, and here instead of having a while or a for loop, we have a conditional statement. In most cases, it will be an if statement, and we're checking to see if that variable has reached the terminal state. So very similar to what you saw previously with the while loop, except instead of a for structure or if or while, we actually have a conditional statement. If we have reached the terminal statement, we then return outside this method. This gets us outside and back. Eventually, it'll get us back to this. Okay. If we haven't reached that terminal state, then we do something. Now, this is optional because it all depends on the problem. At the very least, we're going to invoke ourself or have this method invoke itself, and we need to make sure we increment our value, our variable, so that it gets closer to the terminal state. Otherwise, if I don't do this increment, it will be a infinite loop because I is never changing. And if you guys can recall from early days in 2.301, maybe it's chapter 3 or chapter 4, we talked about the difference between post increment and pre-increment. When we're doing recursion, you want to do a pre-increment of, if you're going to increment your value, your variable as you do your method invocation in the same line, which is something most people do when they do recursion, then you want to do a pre-increment. That way, this guy gets updated first, and then we call the method. If you do a post increment, you call the method again, and once the method is completed, then we update the value, which is something we don't want to do. So just make sure, if you're going to do it this manner, just use pre-increments of your variable. So in this method call, we're going to invoke ourselves. Before we invoke ourselves, we add one to I, and then we come back up here, and we do the same thing all over again. We check it. If it's not good, then we go back here, and we continue to do this until this is now good. Then we return something. In this case, our return needs to be something that matches the int. So we're going to return the int, and then we come back. We actually come back here, okay? And then we just continue to do this all over again. Okay, so let's look at an example where we're going to compute a factorial. And I have, before we actually get to code, let's look at the design of the solution if we want to compute a factorial. I'm just using 5 factorial. If I want to compute 5 factorial, it's just 5 times 4 times 3 times 2 and times 1. Or it's 5 times 5 minus 1, and then multiply that by 5 minus 2, multiply that by 5 minus 3, multiply that by 5 minus 4. And to make this in a very general sense, it's going to be n multiplied by n minus 1, multiplied by n minus 2, multiplied by n minus 3, all the way up until I get to my terminal state, which is n minus n minus 1. So this is how we compute a factorial. Now I just need to write a solution that implements this this design. Let's go back to this slide. We can see the solution is pretty straightforward. The solution is a little more complicated with a recursion. That's not really a good problem to use recursion for, but it is a good problem to use recursion just to demonstrate how recursion can be done. So again, just to be clear, when we're doing a factorial, we would probably do it in a non-recursive way because it's easier. But just so you guys can understand recursion, we've decided to use factorial because we all understand recursion or factorials and understand how to express a factorial. So hopefully you guys can see how this works and how recursion is actually being done in this code. So let's now compare and contrast iteration versus recursion. With iteration, we have a loop body that is controlled by the loop control structure. With iteration, we are checking to see if a value has reached a terminal state using the for or a while. Now, this is more efficient than recursion. That's one good thing about iteration. It is extremely more efficient than recursion. But the negative for iteration is depending upon the problem, using iteration can have a very complicated implementation. Again, when we're doing factorial, you don't see that, but other examples, which we'll discuss in part 2, if we try to use iteration, our solution would be extremely more complicated. Now, when we look at recursion, on the other hand, recursion is where a method calls itself, and then we use a selection statement that controls a loop structure. Last semester I've seen students put a for loop or a while loop inside of when they're doing a recursive method. That is not what you want to do. If you're doing recursion, then inside your that method must be an if statement. Or you could use a switch statement, but I think for the problems you guys will encounter for this section, more likely if will be all you need. And if we use a recursion or recursive method correctly for the appropriate problems, then a positive is it leads to a very elegant, straightforward solution. You'll see that in the next lecture. Now, the negative is always, no matter what the solution, no matter what the problem is, with recursion, there's a higher overhead, which means it's less efficient than iteration. So you may ask yourself, well, how do I know which one to use, iteration or recursion? And the decision is ultimately determined by the design of your solution. I've been talking about designing your solution, I think, since chapter 10, and I even discussed designing your solution in 2.301. The author stresses designing your solution. If you can recall, when we first did the factorial, I actually came up with a design where I looked at 5 times 4 times 3 times. That's the factorial. Then I represented it to. I broke it down all the way down to where it was n times n minus 1 to n minus 2, so forth and so forth. That's what we mean by design. Once we get to a point where I can now have a solution that if I need to do it by hand, I can accomplish. Once we get there, then it becomes pretty straightforward if I need recursion or iteration to accomplish this problem. So you really want to make sure you're designing your solutions correctly, or at least trying to design your solutions. And the hint that I have here is, in my experience, recursion is very useful when we're performing complex mathematical calculations. A factorial is not a complex mathematical complication. But when we're doing complicated mathematical calculations, recursion would be something you may want to consider to use. When we're doing file searching or file processing, recursion would be something you may want to consider. And when we're doing graphics, recursion would be something you definitely would want to consider. So these are just some of the things that I've experienced, and there may be other problems where a recursive call makes a lot more sense than an iterative call. But that will complete part 1 of this lecture, and we will do part 2 later on this week.